Okay, this is my solution for the problem that we did on Monday of week 8. And we were talking about magnetic fields and forces and that kind of thing we were talking about the magnetic field of the Earth and the forces on a charged particle in that Earth's magnetic field. So actually, this problem can be expanded to include all kinds of different problems. But the idea is simply that if you have some kind of magnetic field, let's say, some simple field like you might get in a solenoid, and then you have a charged particle, and it's moving in that field with some speed v, what you get is a force on that particle that is equal to the charge on that particle times its speed, cross product with the magnetic field. And so remember, cross product means it pulls out the component of one vector that's perpendicular to the other. And so what you get here is you get just the v component that's perpendicular to b, and now the direction of this force is perpendicular to all three. So that means that in this case, since I've drawn my vector into the page and my magnetic field into the page, my only two choices are into or out of page. So because the B field and the velocity are both in the plane of the page, the force on this thing has to be perpendicular to that. And what we showed actually is that what happens then, anytime you have a force that's perpendicular to a direction, and here I'll show an end view, that if you have, say, a velocity of a particle going this way, if you have a force that's perpendicular to that no matter what the particle is doing, that means that as the particle goes around, it then feels a force that's inward. And in fact, that's why it goes around. So things go around in a circle because they have an inward force. And so you get these spirals, a helix, a spiral of the particle, and that's what causes the aurora, because now the particle travels along the magnetic field towards the poles and interacts with the atmosphere at the poles. And so what we did was we looked up values. We looked up values for the magnetic field of the Earth near the pole, and we looked up the velocity of the solar wind on Monday of week 8. With those two cool websites that I showed you. Anyway, after that, really, it's just a problem from Physics 161. So we have the mass of a proton, which is what we were considering, times the velocity of the proton, the solar wind, squared, times the radius we're trying to find. And that's the charge, the elementary charge, the charge on an electron or a proton, times the velocity of the solar wind, times the magnetic field of the Earth near the pole. And so the answer is that R, so one of these solar winds goes away, and we found is that the radius is equal to the mass of the proton times the velocity of the solar wind divided by the elementary charge times the magnetic field of the Earth. That's the end.